So here's a pattern that you can prove by induction. All these numbers given here using this pattern: 1007, 10017, 100, so you have like 100, and then 7. You just keep adding these ones. All these numbers are divisible by 1. So if I write a random number like 1, 1, 0, say add arbitrary number of 1s and 7, this number is divisible by 53. So how to prove this? You can just check. So if you start dividing, you can just notice the pattern. 1007 divides by 53. So if I divide 1007 by 53, I get 19. 7 by 53. So you can see the pattern again. So it's like 1889. So the number of 8s will be equal to the number of 1s here. So you can see first couple numbers that are working, divisible by 53. If I want to prove for arbitrary number of ones, so that's something interesting in mathematics, right? So you see the pattern. It's probably obviously that it will keep going like this, but you still need to prove, because there are very interesting patterns, numerical patterns that work up like that work 100 times and fails in the 101st time. The idea is to make sure that it works like no matter how many, like infinitely keeps working. So if you this is going to be the base of induction. If you want to do step of the induction, second step, like transition from n is equal to k to n k plus 1, so we just need to check the difference between these two numbers. So imagine this number. So you have like some number of ones, arbitrary number of ones, 7. And then you have, so this is for n is equal to k plus 1. So you have k plus 1 ones here. And then imagine this number, the previous number. That's like 1 less, right? N is equal to k. So what will be the difference? So the difference is going to be since the last k numbers, k plus 1 numbers. So you have k ones and then 7. These are all going to be 0. So like if I do the subtraction, like subtract the smaller number from larger, you get all zeros. And then here we have like 1 minus 0, 1, and then here 0, and then we have 9, 10 minus 1. So basically, no matter how many number of ones here, to get the next number, so we get the following expression. So a n plus 1 is equal to a n plus 901 and zeros, n times. So by induction, if we know that this is divisible by 53, this is divisible by 53. So when you are dividing by 53, these zeros doesn't matter. So because zeros are tens, tens are 2 times 5. So 901. So if you divide 901 by 53, you get 17. So the second number is also divisible by 53. So if you divide this by 53, you get like 17 and zeros always. So sum of two numbers which are divisible by 53 will give you another number which is divisible by 53 again. So you just keep adding. So you have a number in the first place which is divisible by 53, this one, and you keep adding 53 to this. You keep adding a number that's divisible by 53, and you still get the multiple of 53. So this relation between an and an plus 1 proves by induction that all the numbers, if you do it infinitely many times, it will still be divisible by 53. But the pattern is very interesting. So as you keep adding ones here, the result will keep adding 8s here. So you get, so if I divide this number by 53, I expect to have like 1, 8, 8, 8,